Chapter 5, 5.1 to 5.3, example number 3, equilibrium of a rigid body. Now we have a beam that has a point load at 10 kips, a couple or a moment of 5 kip feet, and we have a triangular distributed load starting at 10 kip foot, and that is 6 foot long. So the first thing we're going to do is we look at what we're trying to find, and we're trying to find all the reaction forces. And my approach is the same: free body diagram and equilibrium equations. So I have my beam here that I'm going to draw my free body diagram on, and I'm going to go ahead and draw AX and AY, since this is a fixed, a point, a pin connection. I have my 10 kip load here. I have my moment at 5 kip feet, and I have my distributed load. So I'm going to do this. I'm just going to kind of dash this in, but then I'm going to put my point load in here. And that's going to be my point load. And then I'm going to draw my reaction force at BY. It's just BY because it's a roller, so it's only holding it in the Y direction. So now let's go back in and let's put our distances. So I know this was 3 feet. I know this was 4 feet. I know this was 3 feet. And now I need these two distances. So if I look at this distance, this is 6 feet. I know I'm going 1/3 the distance from the left side of this triangle, or distributed load. So 6 divided by 3 is 2. And this way I'm going, 1/3. 1/3, not 2/3, 1/3. 2/3 from the smaller side, which would be 4. So those are my distances for the distributed load. The point load equivalent force here is going to be 1/2 the base times the height, that's feet, and that's 10 kip feet. So my feet cancel, so I get 60 divided by 2 is 30 kips. So I've got a point load there at 30 kips. So now that I have everything that I need on my free body diagram, I can solve. Let's do it in red. So I'm going to sum my moment at point A to solve for BY. So I don't have to worry about AY or AX since there is no perpendicular distance. 10 kips, my perpendicular distance is 3 feet. It is rotating clockwise, so that would be negative. And it is rotating clockwise about point A, so that's the point that we are looking at, times 3 feet. I have this 5 kip foot, but it is rotating counterclockwise, so I say 5 kip feet. Now, is there any distance? I already have my distance. It already gives me my distance. I don't have to worry about it. If you're always putting units in here, I'm summing a moment, kip feet, that's all I got to worry about, and I'm done with that piece. Now I come back to this point load. It's equivalent point load. It is rotating clockwise at 30 kips. Now I do have to have a distance here, and this distance is from this point that it's acting on the beam to point A, which is 7, 10, 12. 12 feet, and then all the way to BY, and BY is acting in a counterclockwise, so it is positive. I'm assuming this, and that total distance would be 16 feet. It's all equal to 0. So instead of, well, I could do that. Let's just do negative 30 kip feet plus 5 kip feet minus 360 kip feet is equal to a negative BY times 16 feet. So if I divide it by 16 feet negative, 16 feet negative there. I'm going to get By is equal to, I came up with 22.5 kips. Since I have feet here, my feet would cancel, so I'm just going to have kips. So I have By. If I sum my forces in the Y now, sum my forces in the Y, I have Ay is unknown, which I'm saying is positive, it's going up, minus 10 kips. Do I need to worry about my couple here, or my moment? Now remember, that has a force going this way and a force going this way. They are equivalent, so they cancel each other out, so I don't need to worry about my moment when I am summing my forces, okay? Minus 30 kips plus 22.5 kips is all equal to 0. So if I do this, this is negative 40 plus 22.5. I take it to the other side. I get Ay is equal to 17.5 kips. So I have Ay, I have By. Again, looking at this beam, are there any forces in the X? No. So if I sum my forces in the X, I know immediately that Ax is 0. Since there are no other forces acting in the X direction on this beam. So those are 3 examples. You have 2 problems in the book, and then I'm putting a handout together for you to work on some of these reaction forces. We'll be using them on our frames, we'll be using them on our trusses, and we'll definitely be using them when we get into our shear and moment diagrams in the second part of this 5 weeks. So again, any questions, please post them on the discussion page so that we can have a discussion on them. Thank you.